Okay, so this is going to be me going through implicit differentiation for my midterm on Monday. This is one of the things that I didn't understand fully, along with relative rates and optimization, and a little bit of integrals, but that's later, whatever. So this is for me to look back on, and for my future self to figure out and remember. So when you're going over implicit differentiation, you will always default give respects to x. Give respects to x is going to be dy over dx. And in the problem, it's always going to ask, basically just saying, find dy over dx, or find dx over dy. And dx over dy is just the reverse of dy over dx, where you give respects to y instead of x. And what does that mean exactly? So let's just walk through the problem pretty much. So when you're giving respects to x on the bottom here, dy dx, it's going to be asking find dy dx, or just, find whatever at some point, which, we'll see later. So when starting these problems, you need to first derive every single term. So we start off with x, 2x, easy. And since it's just x and doesn't include a y in it, or like this one, or just the straight up y one, you don't need to add anything to it. You're basically just deriving at this point, which is easy. So now if you go to the next one though, which is y squared, you're going to go 2y, but since you're deriving the y function and you're respecting x, you need to add the dy over dx term here. Then, we go to the next one. This is a product rule, so it's going to be, I'm just going to move this over here. It's going to be a product rule, so it's going to be 2x, so let's derive x first, which is this, plus 2xy. Y is derived here, and since y is the one we are deriving, you have to put the dy over dx. Then equals 16 is just a constant, and then all constants are always 0 when you derive them. So now we have this term here, which looks a little bit interesting. For future reference, remove your parentheses, because it stresses me out less, and it shows that each of these are they're all different constants, basically. So now, moving on. Oops. Okay, so now we need to get everything with a dy over dx term on the same side, so we can, just basically pretend in your head this is like a different constant. This can just be c, or z, or whatever you want to make it. So if we move them all to the same side, we're going to go to 2y dy over dx. They are already on the same side. Okay, cool. 2x dy over dx, and then we're going to move everything else over here. So negative 2x minus 2y. And then now we are at the point where it's easy from here, where we just multiply it out, or take it out of the function basically. So 2y plus 2x equals negative 2x minus 2y. Okay, and now we just need to divide. So now it's just like an algebra problem, so it's easy from here. Oops. 2y plus 2x. So the answer should be this. This equals dy over dx. Okay. And now I'm just going to check my answer really quickly, because I did this before and I got it completely wrong. And the answer is... Wow. Oh, okay. I've just been enlightened to something pretty cool. Yeah, I didn't actually realize this is good for future. You can actually cancel this out. Simplification, whatever. So this, as we can see, a negative 1 can be pulled out here, which makes this 2x plus 2y over another 2y plus 2x, or you can make your terms go whatever way they want if it's just addition. So like this, and then this actually cancels this out, which makes the answer -1. So that one's pretty easy. Then now we have a trig one, which is a little bit harder because it's trigonometry. So, and also this one's going to be at the point 2, 1. And what does at the point 2, 1 mean? This one basically means you plug these in at the end. Like you plug in 2 for x and you plug in 1 for y. But you don't got to worry about that until the end at all. So we're going to take this, put it over here for later. And yeah, basically just start deriving this stuff. So sine, the derivative of sine is cosine and then xy, but you have to chain rule it, so boom, boom, times, that's also product rule, which is, wow, this one is kind of annoying. Okay, times, whatever, good practice. So multiplied by, remember the dy over dx when we're doing any derivatives with y in it. So first we're going to do y, because the x is going to turn into a 1, and then you don't got to change that one because you're not deriving y yet, or you don't got to add this, basically is what I mean. So now this one is where you're going to have to put this into play, which is going to be x. Yeah, it's just going to be x, so dy over dx. Hope this makes sense to me watching it back. Yeah, okay, now equals x plus y. So x is just 1 plus 1 again, but this time it's dy over dx. So we can just get rid of this one. It's just going to be plus dy over dx. Okay, now we have this, and in this case it's better to multiply out because you need to do your get your things on one side. So this is going to be y cosine xy plus x cosine xy dy dx. Also remember to put this at the front because it makes it just easier and better to look at. And I think that's actually how you're supposed to do it. But just remember that. And then equals. Yeah. 1. This one we don't have to change or anything or multiply out or whatever. So now all we have to do is add our terms to the same side. So we're just going to use this side, x cosine xy dy over dx minus dy over dx equals 1 minus y cosine xy. Now we do the same thing we did before, which is we factor out this term. So dy over dx cosine xy minus 1, right? Yes, that looks good. Equals 1 minus y cosine xy. Okay, that looks good. Now all we have to do is our final thing here, which is divide. X cosine xy minus 1, x cosine xy minus 1. Nice. So this should be our answer. Now let me just check if that is right. 3. And if it is, we can move on to our next step. 1 minus y cosine xy over x cosine. Yeah, and it is correct. Cool. I just realized this might actually be a bad situation to plug this stuff in because it's trig and it's going to be weird. So we're going to use a different one. This one seems easy enough. x3 y2 minus y equals x. Also, let's do a different one too. So this one is going to be asking for freaking dx over dy. which is we show respects to the y, meaning we will actually, well, I'll show you what it means basically, at 2, 1. So, starting this out, we have this term over here with the product rule, so we're going to do x, or shoot, 2x3y. Here we are deriving the y because of the product rule, but we're not adding the dy over dx because it's reversed this time, and we're actually giving respect. Oops, I think I just took it. Is this okay? No. We're actually giving respects to shoot, y this time, so it's different. Okay, fine, it's good. So anyway, we're gonna keep doing this product rule. So now it's 3x squared y squared, but we need to put the dx dy here because it's reversed. Now this term is done, so now minus 1, but it's y, and we're giving respects to y, so it doesn't matter, equals x, which is also 1, but you know, we need to put this here because it is different, whatever. Okay, so we're here now. I can just do this. Okay, so what I'm looking at here is two terms that need to be on the same side at 2, 1. So let's go ahead and put these terms at the same side. So 3x squared y squared dx over dy minus dx over dy equals 1 minus 2x 3y. Okay, perfect, easy. Now we just do what we've been doing, which is factor this out. 3x squared y squared minus 1 equals 1 minus 2x 3y. So finally, all you do is divide this by this, y squared minus 1. Now this is where the new stuff comes in, where we need to at 2, 1. And at 2, 1 basically means all you need to do is plug it in at x at the 2 and the exit and the 1 in the y's. So 1 minus 2 times 2 to the third times 1, all over 3, 2 to the second, 1 to the second, minus 1. This is 1 minus 16 equals negative 15 over 4. 12 minus 1 is 11. So negative 15 over 11 is our final answer. And this is what the answer would be if it's not at 2, 1. This is just the thingy. So yeah, that's pretty much the entirety of implicit differentiation that's going to be on my exam. So I think I don't really have to visit that anymore, except when I'm like, honestly, I think I have it pretty much down. So anyway, moving on to whatever's next.